Okay, we're going to look at angles of elevation and depression. So let's start off with the definition. The angle of elevation is the angle between the horizontal and the line of sight when looking up. Okay, so just imagine you're standing here at the bottom. So imagine your eye is there. There's your eyelashes. All right. So the line of sight is along the hypotenuse of the triangle. So you're looking up at something. So maybe, for example, there was a bird up there that you're looking at. All right. Now the horizontal is the horizontal part of that triangle. Okay. So the horizontal line is there. So the angle between the horizontal and the line of sight, this angle here, which is theta, that's called the angle of elevation. Now what about the angle of depression? Well, just imagine this time you're on top of a roof or a cliff or something. Just say it's a cliff. Just say your eye is here. Here's your eye. Eyelashes. There we go. This time your line of sight is looking down along the hypotenuse. That's your line of sight. Maybe you're looking at something below. Maybe it's like a little boat. Here it is. There's your boat. There's the waves. Okay, so you're up the top here. Now the angle between the horizontal line there and your line of sight, so this angle here, that's called the angle of depression. So just in there, that is the angle of depression. Right, so the angle when you're looking down, the angle between the line of sight and the horizontal when you're looking down. Okay. Now, a couple of things to note about the angle of depression. First of all, BC is parallel to AD, and that means angle ADB equals CBD because alternate angles and parallel lines are equal. So let's have a look at why that's true. So I'll get rid of my sketches there so you can see all the letters. Okay, so now this line here is parallel to this line here. And that means we have a pair of alternate angles which are equal. This angle here and this angle here are equal, which means if that's theta, this is theta. Okay, so we say that angle CBD, so angle CBD is equal to angle ADB, right? Equal to theta. All right, and the reason for that is alternate angles. Well, these two angles are alternate angles. The two angles marked in blue. Alternate angles and parallel lines are equal. Okay, so keep that in mind. Now, first example, you've got to mark in the angle of elevation, theta, and find its size. Okay, well, remember, it's the angle when you're looking up. So here's my line of sight, just there, I'm looking straight up. Imagine you've got a little eyeball there. There's your eyelashes, and you're looking straight along that hypotenuse. So this here is the angle of elevation, and I'll mark it with the angle of theta. And it says find its size. Well, we know there's a pair of parallel lines in that diagram. There and there. And I've got to use double arrows because I use single arrows for that line there. So double arrows. So that angle there, 30 degrees, is equal to theta. So theta is equal to 30 degrees. And usually you've got to put the reason. So you'd say alternate angles on parallel lines are equal. Okay. All right, let's go to the next one. You're going to mark the angle of depression. Now, the angle of depression is when you're looking down. So just imagine you're up the top here, and here is your eye. Here's your eyelashes. And you're looking down. Okay, maybe there's a boat below. There's your boat. All right, so the angle between the horizontal and the line of sight. So the line of sight is with the red arrow. The horizontal line is the dashed line. So it's this angle here is your angle of depression. And then it says find its size. Well, this angle here and is equal to theta because of alternate angles. So theta is equal to 43 degrees. Okay, and the reason being, same thing as before, alternate angles on parallel lines are equal. Then where are the parallel lines in this diagram? Well, let's use double arrows. This line here is parallel to this line here, which means these two alternate angles must be equal. Okay, so the angle of depression, by the way, the angle of depression was theta, wasn't it? That's the angle of depression just there. All right, so let's put that into a question now. Problem solving. It says the angle of elevation of a chimney is 49 degrees at a distance of 85 meters from its base. Find the height of the chimney to the nearest meter. Okay, so what we're going to do is we're going to draw our chimney. Oops, I'll make it a bit neater. Right, I'll make it a vertical line, roughly. So there's my chimney. Right, and it's got a height of 80. No, we don't know what its height. We've got to find the height. So there's h for the height, and it tells me the distance from the base of the chimney. So this is the base here. There we go. The distance from the base of the chimney is 85 meters. So let's just complete the triangle. There we go. There's my triangle. Okay, so 85 meters. So you've got to draw a picture first. There's my right angle. And it tells me the angle of elevation is 49 degrees. So this here is the angle of elevation. So there's my eyeball, if you like. I'm looking up. Here's my line of sight. That's why it's the angle of elevation. So to the nearest meter, we should be getting 98 meters. So let's have a look at that. We're going to have, first of all, label the sides, opposite, adjacent, and hypotenuse. So we're going to, here's my angle. So this is the opposite side. This is the adjacent side, and this is the hypotenuse. Now the two sides you're working with are this side and this side, which means it's opposite and adjacent we're looking for. So it's got to be tan. Let's write down tan theta equals opposite divided by adjacent. And then tan 49 degrees is equal to h over 85. All right, so I'm going to times both sides by 85 to get the h by itself. Okay, that 85 cancels with that 85. So you're left with h. So you've got 85 times tan 49. So you've got to get your calculator out and work that out. Okay. So 85 times tan 49. You should get 97.78, and it keeps going. But it says to the nearest metre, so you're going to approximate that and say H is approximately 98 metres. Okay. All right, so copy that down. Let's have a look at the next question. All right, so we've got the angle of depression of a boat from the top of a cliff. So let's draw our right angle triangle again. So vertical line for the cliff. Okay, and it says the boat is 350 metres from the base of the cliff. So just draw that there and then complete the triangle. There we go. All right, so put in the right angle. Here we go. Now it says the angle of depression from the top of a cliff is 8 degrees. So that means you need to have a dashed horizontal line starting at the very top. Okay, now that angle there is my angle of depression, and it's 8 degrees. Okay, so you've got to put that in. And it says the boat is 350 metres from the base of the cliff. So there's 350 metres. By the way, the cliff is there. And the boat, here's the boat. There we go. And you've got to find the height of the cliff. So it's this one here. All right. Now, notice we have this as 8 degrees. Okay. Now, there's two ways we could do it. First of all, we can say, well, if that's 8 degrees, then this must be 8 degrees down as well, because these two angles are alternate angles. So they must be equal on the parallel lines. Here's your parallel lines there and there. So let's do it that way. So we'll start off by saying label the sides. So you're going to opposite here, adjacent here, hypotenuse here. And that's going to give you, now the two sides we're working with are this one and this one. So that's tan again. So right, tan theta equals opposite over adjacent. So if you look back at the previous working, okay, it should be the same. All right, so you're going to now replace all the numbers. So there's my 8 degrees. So I'm going to put that in there. Tan 8 degrees equals the opposite side, which is H over 350. And then you're going to multiply both sides by 350 to get the H by itself. So times 350, cancel. And that gives you H is equal to, so you're going to get 350 times tan 8. So 49.18 dot dot dot. But you're going to approximate that to the nearest metre. So it'll be 49 metres. Okay. All right. Now, could you do that question differently? And the answer is yes, because you could do it this way as well. We know that this angle here is 90. So if that's 8 degrees, this is 72 degrees. Okay, so you could have done it that way. And if that's 72, then you'd have to basically relabel the sides. Just change colours here. So that means this would be the opposite side, and this would be the adjacent side. So if you did it that way, you're still using tan because you've got the opposite and adjacent. So you'd write down tan theta equals opposite over adjacent. And then this time your theta is 72 degrees. So you're going to have tan 72 degrees is equal to 350, because that's the opposite side now, divided by h. All right. Now, if that's the case, you're now going to the next step is swap these terms around. So you then go h, h is equal to, what is it? Let's get rid of that. All right, so you're going to go h is equal to 350 divided by tan 72, which equals 113.7. That didn't work out, did it? Hang on. 350 on H. Oh yeah, I can see why. Because that's not 72, it's 82, isn't it? Okay. All right, so let me fix that up. All right, so eraser. That should be 82. Okay, my bad there. 82 degrees. All right, that'll work. So then I'll come back over here and I'll have to change that to 82. Okay. So 82 degrees, here we go. And then this will be 82. So I'll just fix it up so it's clearer. Okay. $82, and that means it's not 113, of course. Let's try that again. 350 divided by tan 82, 49.18 dot dot dot. So 49.18 dot dot dot, which is equal to approximately 49 meters. So you should get the same answer, whichever way you do it. Just make sure you do subtractions properly. All right, let's have a look at the next question. Last one. Right, so from the top of a cliff 96 meters high, Ed sees a boat floating 235 meters from the foot of the cliff. So let's draw that triangle in. So here's my cliff, the vertical line. And then from there, we've got a 235 meter distance. Okay, so same diagram essentially, right angle triangle. Let's put the right angle first. There we go. And then 96 meters is the height of the cliff, so I'm going to put 96 meters. Ed sees the boat floating 235 meters away. Okay, let's just fix up that. Should be 3 there. The angle of depression. This time we've got to find the angle of depression. Okay, so this is the angle that I've got to find. That's the angle of depression. Now I need an angle inside the triangle if I'm going to use trigonometry. So if that's theta, this is also theta. Okay, and then this is the opposite side to that angle theta, and this is the adjacent side. So the two sides I'm working with are opposite and adjacent. Now it won't always be tan in the examples, but in this case it is again. Tan theta is equal to opposite divided by adjacent, and then tan theta is 96. 1, 2, 3, 5. And then on your calculator, you need to use the tan minus 1 button there to find the angle, which you've done before. So you should get, I'll put on my calculator, shift tan 96 on 235. Should get 22.2 degrees. Okay, degrees because we're using angles. It says to the nearest degree there, so you'll get 22.2, and it keeps going. So you round that to 22 degrees. Okay, so that's our last question. So make sure all that's copied down and then get stuck onto the exercise.